Hello, in this tutorial we'll be creating a Solidity smart contract, deploy it on two different chains, and use ZetaChain's cross-chain messaging to send a text message from one contract on one chain to a contract on a different chain. So let's get started. First of all, you want to clone a template from ZetaChain's GitHub. ZetaChain/template. Clone that, you will get a new template directory. Once you open it, it's a standard hard hat template. To install dependencies, just run yarn or npm, and you're ready to go. To create a new cross-chain messaging contract, you can use the command available from the toolkit. Type npx hard hat messaging. This command accepts a name of a new contract and a list of arguments. It creates a new cross-chain messaging contract and a set of hard hat tasks that help you deploy and interact with the contract. So let's use this command and create a contract called myContract. It's going to be very simple. It will accept only one message, one field, and we'll call it text. We're not going to change the type. You can put a colon and specify a type, but we're okay with the default type. And what these fields are, they are the bits of data that gets transferred from, it's basically the contents of the message. So we just want to have one field called text, and that's it, but you can have more. So let's create my contract, and you can see 3 files were created: a deploy task, an interact task, and the contract itself. So let's first deploy and interact with the contract and then review the code. First of all, we need to compile the contract. So type hard hat compile force, it will compile the contract, and now we're ready to deploy. Before we deploy, make sure that you have tokens on your account. If you don't have an account yet, type hard hat account, save. It will create a new account and store it in .env. I already have an account, and use the faucets available in the docs to get the tokens, both on connected chains primarily. So we're going to be deploying the contract to Goerli testnet, and we'll be sending a message to Mumbai. So now that we have compiled the contract and we have tokens on our account, let's deploy. To deploy, we use the deploy task and specify a list of networks. First is Goerli testnet and Mumbai testnet. What this task will do is it will first deploy contracts on both chains, and then it will set interactors for both contracts. What is an interactor? An interactor is basically an address of the counterparty contract. So for a contract on Mumbai, an interactor is an address on Goerli. Very straightforward. This is for contracts so that they don't have to accept messages from any contract that they're not supposed to accept messages from, and for ZetaChain to route messages correctly. So you can see that on Mumbai it set the interactor the same as the contract on Goerli. Let's wait for it to finish setting interactors, and we're done. Now we're going to actually send the message now. To do this, use the interact task. It accepts a few arguments. One is amount. So amount is the amount of tokens in the native tokens of the chain that you're sending message from. So in our case, we'll be sending from Goerli to Mumbai. That's going to be ETH. And we need to figure out how much ETH we need to provide for the contract to cover cross-chain fees. We can use the fees command to determine that, and it will tell us that to send a message to Mumbai, we need to provide this amount of Zeta. So it's in Zeta. To understand how much that is in ETH, we can go to Uniswap, then go to the docs, copy the Zeta token address for the Ethereum testnet. Copy it here, we already have it copied, and we say like we need 2.1. So it's around 0.01 ETH. That should be enough to cover cross-chain fees. So let's do that. Let's run npx hardhat interact, help to see parameters again. Amount is going to be 0.01 native token, which is ETH. Contract is the contract on Goerli. Destination will be Mumbai testnet. And the text is just going to be hello. So what this command did is it called a method on the contract on Goerli to send a message of hello to a contract on Mumbai, and it returned a transaction hash. What we can do next is use the cctx command to actually track this transaction in real time. So right now it's going to start looking for cross-chain transactions on ZetaChain. While it's doing that, we can review the code and see what actually is happening under the hood. So we have my contract, which inherits from Zeta interactor and Zeta receiver. In the constructor, we only need Zeta token because that's the token that we're paying for the cross-chain fee in. And we need Zeta consumer, which is a helpful service, on-chain service that lets you convert your native token into Zeta. So the first function we're going to look at is send message. This is the function that gets called when you want to send a message, and it only accepts a destination chain ID. So where do you want to send it? We provided it with 8001, which is a chain ID for a Mumbai, and a string of text. It does some checks, then it converts the token, the native token, into Zeta. So it uses Zeta consumer for that, and then approves Zeta tokens to be sent to the connector to cover cross-chain fees. Next, it's using the connector API to send a message to the destination chain ID, to the destination contract. It's getting this from the interactor that we set after deploying, and it's sending a message type, which is useful if you want to send different kinds of messages, and the actual message, which is text. This is what's happening on the sender side, in our case, Goerli. On receiving end, we have to implement onZeta message, which gets called whenever a message is successfully delivered to the destination chain. The only thing that this is doing is decoding the message using ABI decode and emitting an event. It's also checking for the message type, but it's not that important in this context. So it's just emitting a message with the text. OnRevert gets called when a message is delivered, not successfully, hasn't been delivered, and this is getting called on the source chain. So send message is getting called on the source chain, on Zeta message, on the destination chain, and on Zeta revert, again, on the source chain. This is useful if you want to clean up some data that you set when sending a message. For example, if you're sending an NFT, you might be locking it when you're sending a message. You might want to unlock it if the message wasn't transferred successfully. So this is pretty straightforward. You can modify easily. You can modify this contract easily to support different types of data. You can send an arbitrary values using cross-chain messaging. Now let's take a look at the deploy task. In the deploy task, there are two things happening. One is we're actually deploying a contract. So we're taking the connector address, we're taking Zeta token and the consumer and deploying a contract. Once the contracts are deployed, we're running set interactors. So this is the logic for setting interactors. It's very straightforward. You're just calling a contract and setting an interactor based on the other contracts that you have deployed. So you can deploy it to 2 chains or 3 chains. Currently, ZetaChain supports 3 chains, Ethereum, Polygon, and BSC. So you can deploy on all 3 and send messages between these chains. Now let's take a look at the interact task. So interact task is very simple. It just calls the send message method on the contract, and it passes all the values. First of all, of course, the amount in the value, then text, and destination chain ID. So when you call interact, the send message method gets called. So these values are simply passed to the send message method. My contract by default supports paying fees in the native token of the chain. That's why we need Zeta consumer is to convert native tokens into Zeta to cover cross-chain fees. This is very convenient for end users because they don't need to have Zeta. They can just provide the tokens that they already have on the chain that they're sending a message from. But you can also imagine a scenario where it's easier to provide Zeta as a fee. So you wouldn't need to do all this conversion. So you can do that by passing an argument before you created a contract. You can do this in the messaging command with the fees option. So by default it's native, but you can also provide fees Zeta, and in this case you will be actually paying with Zeta tokens for sending a cross-chain message. So it's really up to you what is more convenient for you and for your users. But by default, we assume that it's easier to pay in native tokens. So while we're waiting for this transaction to be processed, we can take a look at the docs where you can learn more about cross-chain messaging. Go to zetachain.com/docs, and in the overview section you can actually see the short version of what we've just reviewed. Right? It's the three methods that you need to implement for sending messages, receiving, and reverting. You can read more about the connector API, which facilitates cross-chain messaging. You can actually find the source code of all the protocol contracts, including the connector, in ZetaChain's GitHub under protocol contracts. If you go into the contracts directory and check EVM, you will see that there is a connector contract, so you can check it out to see how exactly it works. But yeah, you can read more about it in the docs. And we have a set of tutorials. We just covered this one, first cross-chain message, very straightforward. We also have tutorials on value transfer, implementing a simple cross-chain counter and transferring NFTs between chains. Now that our message has successfully been transferred from Goerli to Mumbai, we can go to Polygon Scan, open the contract page, click on Events tab, and see that the text hello has been emitted from the contract. So this is how easy it is to send messages from one chain to another using ZetaChain's cross-chain messaging. Please check out the docs, and if you have any questions, feel free to ask them on Dev General channel on the official Discord. See you in the next one.